Hello everyone. Today we're going to talk about our last video to sum everything up for this unit, for this portion of the unit, and it's called solving quadratic equations. I'm going to do my best not to there it is, not to cough, and just sort of bear with me. I'm sorry if I'm coughing into your headphones or your computer. So when we started this unit on factoring and how to find the different factors of a quadratic, we said that the ultimate goal was to be able to solve the equation. Okay? So far, we've been doing factoring quadratics. We've been talking about how do you factor quadratics for all the possible situations, and now we're going to take that last step and find the solutions. Another word for solutions are x-intercepts. X-intercepts or roots. So the solutions to a quadratic could be written as x equals a number or as an ordered pair, x, comma, 0. Now, when we spoke about finding the solutions, we talked about this is where it crosses the x-axis, right? These are the x-intercepts. So the reason why we put 0 here is because whenever we're graphing a quadratic, no matter where it lands, those x values, the y value associated will always be 0 as the x-intercept. Okay, and that's going to be very useful in doing this very last step and finding the solution of a quadratic equation. So let's get to it. All of today will really be most of a review to help us solve these quadratics. So we will do an example of every type of quadratic we've done so far and just show you how it's the next step on how do you solve it. If you've been really good about everything else, then you can probably watch the first 2 examples and then skip to the very end so you can see some last minute pointers that will also help you with solving. Okay? But if you're like, I'm still trying to get the hang of this stuff, then today would be a really good review day to cover all the types of quadratics that we have done so far. Here's our first example. So the only thing that we're really changing here is we are interested in when is this function going to equal 0? When is the y value, right? F of x is the same thing as y. When is y going to equal 0? Because that's when it crosses the x-axis. So, I'm sorry guys. The first step you want to do is change it to 0. So we have 0 equals x squared plus 7x minus 30. And this is factorable. So when we factor, we have x times x. And here, hopefully you know, we have 6 times 5, 3 times 10. We have a lot of possibilities. I'm going to go with 3 times 10 because that combines to a 7. Now one of these has to be negative, right? I'm going to make the 3 a negative because when I cross multiply, I get 10x and negative 3x. And that does combine to positive 7. Hopefully you're feeling comfortable with that by now. If not, just keep trying. You'll get the hang of it. It's all about practice. So here are my 2 factors. X minus 3, x plus 10. So 0 equals x minus 3 and x plus 10. Now that you have the factors, now we can find the x-intercepts. So we're going to set each factor equal to 0. Separate into different problems. So we have 0 equals x minus 3 and 0 equals x plus 10. When you solve for x, you just basically isolate the variable, so you move the 3 over. Here we have x equals 3, positive 3. And over here, when we subtract 10, we get x equals negative 10. Those are my x-intercepts for this quadratic. Okay? Now you can see them like this or as an ordered pair. You can even write it as 3, 0, because that's the y value. This is the x. This is the y. And you can write it as negative 10, 0, because this is the x value and this is the y. Alright, so this is basically what we're doing. The only step that we're going to be adding to this, right, this whole unit, is this last piece. Now that we know that this function equals 0 for y, we're going to solve for the last step and find the actual x solutions. The x answers, the x intercepts, the roots, whatever you want to call them. Okay? Before we would stop here, now we're looking at one last step. So, like I said, a bit of a review. In this example, in the previous example, a was equal to 1. In this example, a, if you look at a, does not equal to 1. And none of these, not all of them have a number in common. So this is a scenario where we have a not equaling 1. I still factor it, right? I still want to change this to 0, so I make this equal to 0. So I have 0 equals 3x squared plus 8x plus 5. As I find my factors, I get 3x times x. And on the right side, I have 5 times 1. Now where do I put the 5 or the 1? Well, I'm going to put the 5 on top and the 1 in the bottom, because when I cross multiply, I get 3x here, I get 5x here, and I add it up to actually 8x. So my factors here are 3x positive 5, x positive 1. So 0 equals 3x plus 5 times x plus 1. Those are my two factors, right? Now the last step here, of course, is we set them each individually equal to 0. So we have 0 equals 3x plus 5, and 0 equals x plus 1. As I solve for x, I subtract 5 on both sides. Negative 5 equals 3x. Divide both sides by 3. You get x equals negative 5/3. That's my first solution. My next one, I subtract the 1 over, and I get x equals negative 1. Whenever you get a situation like this, right, most of the time you will see the answer as a fraction, not as a decimal. But if you look at your multiple choice questions and you don't see a fraction, you see it as 1.6 or whatever. Yeah, 1.666, then you would choose as a solution. But most of the time, like 99.9% of the time, we see it as fractions if it comes down to this where it's not divisible by it equally. Let's try another one. Here's another situation where we have where a does not equal 1. And if you notice here, they all have a 2 in common. So I'm going to first change this to 0. Okay. Since they all have a 2 in common, I'm going to show you a shortcut to simplify this process. Okay. So I'm going to say 0 equals, pull out a 2 from everything. So divide every single term by 2. Here, when I take out a 2, I'm left with, divide this by 2, right? The 2 is going to cancel. Or, if we do, as we said earlier, reverse distributive property, 2 times x, sorry, 2 times x squared gives you 2x squared, right? We're doing this reverse distributive property here. 2 times what gives you negative 10x? That's a negative 5x. And then 2 times what gives you positive 8? 2 times positive 4. Now, I can sort of leave the 2 on the side, and I can just factor this because it's in simpler terms. You see? So I here have x times x. Over here I have negative 4 times negative 1. To get that third column, if you notice, if you cross multiply, negative 1x plus negative 4x does in fact give you negative 5. So my solution, my factors are x minus 4 and x minus 1. So this is how you would write it. You'd have 0 equals 2 in the front that we pulled out, x minus 4 and x minus 1. The 2 stays out in the front, and we still have 2 factors of x. So all we're doing is we're going to set each of these equal to 0. Notice how the 2 is going to disappear in a minute. So I still do 0 equals 2. 0 equals x minus 4. And 0 equals x minus 1. I set each of them equal to 0. 0 is never going to equal to 2, so we just drop that. That makes no sense. And I can solve the rest. So basically, whatever factor you pull out in the very beginning, right? Like if you pull out a number from all of them, it only works if it's all of them have in common. If you pull them all out, right, you still have all your factors, but that first factor that's just a number is not going to have an x-intercept because there's no x values. And that's why it's always going to disappear at the end. Okay? Here I just solve the rest. So I add 4 to both sides. X equals positive 4. I move the 1 over to the other side. And x equals positive 1. And those are my factors. Now you might have a question that says, just factor this equation, and you stop here, right? You factor out the 2. But that's still a solution if it's looking for the factor. If it's looking for the solution, then you're down here where you're solving for x and the 2 disappears. The 2 only disappears if you're looking for the solution, not if you're looking for the factors. So if it says factor, this is your full answer. If it says solution, then that's when we ignore the 2, and this becomes your full answer. Because they mean 2 different things, right? Solutions are x-intercepts, and factors are things that multiply to give you this original equation. Let's take another example. Here we have a scenario where we don't have a beat x term in the middle, right? This is like the last video we did called differences between 2 squares. We're still trying to find the solutions. You can do this doing Lopez approach, right? That method I showed you, where you added 0x in the middle. So you can solve it as 0 equals x squared minus 49, or you can do 0 equals x squared plus 0x minus 49. They're both going to give you the same solution. If you prefer Lopez approach, go about it this route, do your 3 columns. If you don't, or if you know that this method is going to be a lot faster, remember that when we find the factors, there's 2 of them, and they both have a square root. You're going to take the square root of the first term, which gives you x. So you're going to have x twice. And then the 49, the square root of 49 is 7. So you're going to have 2 7s. But remember, one of them is positive, and one of them is negative. So now that we have our factors, you would get 0 equals x plus 7, and 0 equals x minus 7. Solve for x on both equations. You subtract 7 on this side. You get x equals negative 7. And over here, when you move the 7 over, you get a positive 7. And there are your 2 solutions. If you did it this other route, you would reach the same destination. So here are my factors. Here are my solutions, the x-intercepts. We're almost done, guys. In this scenario that we talked about, notice how there's no c value, that you can include a plus 0 at the end, and you can still do Lopez approach with your 3 columns. Or if you remember, do these 2 have anything in common that we can factor out? So I'm going to write this problem or equation as, I'm not going to do this using Lopez approach. I'll show you how you can do both, I guess, if you want. The setup would be 0 equals 3x squared minus 15x. Or if you want to do Lopez approach, you could do 0 equals 3x squared minus 15x plus 0. Alright, here I have my 3 columns. Over here I don't. So I'm going to do it the other way on this left side, just because I showed you how to do this in the most previous video. But if you want to do Lopez approach, you'll always get the same solution. Okay, as long as you remember that it's missing a term, and you can add it there at the end as a 0 because it doesn't change anything. These two terms have a 3 in common, right? This is divisible by 3, and this is divisible by 3. And they both also have an x in common. So I'm going to take out a 3x from this equation. So I have 0 equals 3x. And I'm doing reverse distributive property, right? 3x times what gives you 3x squared? X. 3x times x gives you 3x squared. 3x times what gives you negative 15x. And that already has an x, so I only have to include the number, the negative 5. Remember, with this method, if you prefer it this route, you're going to want to do like reverse distributive property to check your work. Is it 3x squared, and is it negative 15x when you multiply inside? And the answer is yes. If you do Lopez approach over here, okay, you'll still have the same factors, except that one of them will be 3x plus 0, and the other one will be x minus 5. Okay? They're very, very identical except for that 3x in the front, right? 3x plus 0 is the same as 3x. So I solve both of them, set them equal to 0. 0 equals 3x, and 0 equals x minus 5. On the left side, I have to get rid of the 3, so I divide both sides by 3. 0 divided by 3 is equal to 0, so x equals 0. You move the 5 over, you get x equals positive 5. So x equals 0, x equals 5. Those are your two solutions. If you went about this route, you get the exact same thing. You see how this whole thing is just a big review? We're just adding this last final step of finding the solutions. We used to stop here at the factors. Now we're solving for an actual x answer. And remember, you can always write it as x equals, or you can write all of these as ordered pairs, right? Or you could say 0, 0, and 5, 0. The x values are my answers, and the y will always be 0. That's why we changed this original problem to y equal to 0, because that's when we're interested, where it crosses the x-axis. Alright, this is the last possible scenarios that you're going to see, right? Now these are very identical to what we've done. There's nothing different, but I do want to show you like what happens when we don't have f of x here anymore. What happens when you have like an equation equaling something else? In order for you to do the quadratic formula, sorry, that's later. In order for you to do factoring or any of these methods, this function has to equal to 0. Okay? So this part has to move to the other side for this to work. So all I'm going to do before starting a problem when I see something like this is I move the 15 over. So do the plus 15 on both sides. On the left, negative 15 plus 15 gives you 0. And on the right, you have x squared minus 8x plus 15. Excuse me. Now that you have your function equal to 0, now you can continue to solve this problem into your 3 columns. You'd have x times x. You would have negative 3 times negative 5, right? You find your factors, you find your solutions. The biggest thing that I want to show you here is that this is still solvable. You just have to move it over first and then begin your process. So if you follow the work and you continue doing the steps, you should end up getting x equals 3 and x equals 5 as your solution here for this one. On the right side, this is not in standard form, and it's also not in vertex form. The great thing about this one, it's already given you the factors. You don't have to find the factors like you did down here. Right? Down here, we found the factors as x minus 3, x minus 3, and x minus 5. And then, what do we have to do? We set each equal to 0. So we set this equal to 0, and the right side equal to 0. So that you can get the solution, x equals 3, and x equals 5. here, we're already in this step. We can skip all of this nonsense because we're already given the factored form of it. So all we have to do is change the y to 0. And since it's already in factored form, just set each equal to 0. 0 equals 2x minus 2, and 0 equals x plus 3. As you solve, you get 2 equals 2x. Divide both sides by 2. X equals 1. Over here, we subtract 3 on both sides. We get x equals negative 3. And those are your solutions. So the great thing about having it in this notation already is you don't have to factor them because you're given the factors, right? So there's so many possibilities. These cover all the possible scenarios, right, that we're going to be talking about for factoring. I wanted to expose you to a bit of a review and also show you how to solve all of these when it comes down to factoring equations, right? Later we'll talk about the ones that are like not factorable. That's in the next piece. Or like, how do we solve a quadratic that I can't find the factors for? So for those kind of equations, I'll show you a different method starting next week. For now, I hope this helps review every possible solution or possible scenario, right? And the last thing I can show you, I guess, if you want to check all of your work, is you can always type in the equation in Desmos. Always. Oh, Desmos is always a solution, as long as you know what you're looking for when it comes down to the solutions. Okay, now this is not doable for all the problems, just because some problems ask you to find the factors, and some problems ask you for solutions. So if it's asking you for the solution, you can always just graph it and check where does it cross the x-axis. Locate those points, and you got yourself your solutions. Now, some of you are probably upset, like, say, well, why didn't I just do it this way? Why do I have to do all of that work? For 2 reasons. One reason, you're not always asked for the solution, right? Up to today, everything we've been asking for is find the factors, and there's a lot to that, right? As you move later in math, you're gonna need to know how to factor an equation, and not always interested in finding the solution. So that's one case. 2. If it does tell you just find the solution versus the factors, you can always plug it in to Desmos, as long as the equation is in f of x equals format. If you have a number over here, you have to move it over to the other side before you can graph this. Okay? So you can find your solutions. I hope this helps. I'm sorry for all the coughing, guys. I really miss y'all. I'll see you guys really soon. Okay? And as always, I will calculate it.